Good afternoon. I am Dr. P. Usharani, Professor, RMD Engineering College. I am going to brief about the topic of capacitive transducer. Capacitive transducer is a passive transducer. That means it needs the external power source for its operation, which is generally useful for displacement, pressure, or other physical quantities to be measured, which uses the what's the difference between capacitor and capacitive transducer? If you take care, capacitor, there are two plates. The distance between them is fixed. We cannot change that one. Here, the capacitive transducer consists of two plates, one top plate and another bottom plate. In between dielectric medium, which is air or gas or liquid or some material. So the variable capacitive transducer depends on the changes in variations of dielectric constant or overlapping of the plates or the distance between them. So the major difference here, we can vary the distance between the plates when compared to normal capacitor. So the general formula for capacitance is epsilon A divided by D, or here epsilon as epsilon R epsilon naught into area divided by distance. What is epsilon naught as permittivity of free space? The values 8.854 into 10 power minus 12, and your T as distance between the two plates, A as overlapping area of the plates. By varying all the parameters, that is the area you can vary, overlapping area of the plates I can vary, or distance between the plates we can vary. Depending on that, your capacitance may be varied. So I am going to take one problem for solving. A pressure measuring instrument uses a capacitive transducer having a spacing of 4 mm between its diaphragms. A pressure of 600 kilonewton per meter square produces an average deflection of 0.3 mm of diaphragm of the transducer. The transducer, which has a capacitance of 300 picofarad before application of pressure and is connected in an oscillator circuit having a frequency of 100 kHz. Deduce the change in frequency of the oscillator after the pressure is applied to the transducer. They have given the frequency F1 and the capacitance value C1 300 picofarad, and they are asking before applying this is the value, after applying what is your capacitance. Okay, change in frequency. So I'm going to use the formula of general formula capacitance epsilon A by X, or here the values given are average deflection as 0.3 mm, frequency F1 as 100 kHz, X1 as 4 mm. So I'm going to first work out using this formula. I calculated epsilon A value. Epsilon A value as capacitance C1 as 300 picofarad. So I have substituted 10 power minus 12 into 4 mm. So 4 into 10 power minus 3. My answer is 1.2 into 10 power minus 12. Whereas my x2 value as x1 minus delta x. Delta x as 0.3 mm. So here 4 minus 0.3, 3.7 mm. So I used this formula C2, which is epsilon A divided by x2. Now epsilon A won't change. Epsilon A we have calculated 1.2 into 10 power minus 12 divided by x2 I have substituted 3.7 into 10 power minus 3, which is the 324.32 picofarad capacitance value. Now I am going to find out the frequency at the time. So using the formula of F1 by F2 is equal to square root of C2 by C1, or F2 as F1 into square root of C1 by C2. So I have substituted the values 100 into 10 power 3 100 kilohertz into C1 value as square root of 300 in picofarad and C2 value as 324.32 picofarad. So after solving this, frequency as 96.177 kilohertz. So the change in frequency as F1 minus F2, which is 100 kilohertz minus 96.177 kilohertz, which is the answer 3.823 kilohertz. So the capacitive transducer generally useful for measurement of pressure, displacement or any other physical quantities, which is a passive transducer. That means it needs external power. And the difference between normal capacitor as the distance between the plates, metal plates or top plate and bottom plate are fixed there. Here we can vary. So that's the major difference. By varying the area or the distance, we can change the capacitance values. Thank you.